Hello, everybody. This is Alex. I'm coming to you on the Astro Imaging channel. Tonight, we have the privilege of having Bob Denny. Bob Denny's been an innovator in Astro Imaging and controlling your computer and everything else. I think somebody's got, that may be me. Hang on for a second. Yeah, it was me. Bob's going to tell us about some new developments. We all know, or we should know, what ASCOM is, but we're going to be taking ASCOM a few steps further, and I'm not going to take a lot of time to tell you about it because the master himself is here. So Bob, take over. Okay, unmute yourself and get in there.
All right, thank you very much. As Alex said, I'm Bob Denny, and I am the person who originally back in 2001, came up with the concept of applying the driver-client architecture, which had been around in computing elsewhere, to astronomy, which is where ASCOM came from. So yes, I'm the originator of ASCOM, and I designed the initial, interfaces and all of that. And so it has taken an awfully long time to catch on. It probably, I would say, 4 or 5 years maybe. And then it started to really build up a head of steam. And by now, I think we could all agree that ASCOM's pretty pervasive. And for most things, it supplies a standard sort of way for things to talk together. What I'm going to talk about tonight is an extension to ASCOM to extend it out beyond Windows to other platforms. And I'll get into that just 2 seconds while I get, once I get my screen shared here, just a sec. One more time. Click, click. There we go. Okay, as I said, I'm Bob Denny. We're going to be talking about a new technology called ASCOM Alpaca. Alpaca is a new set of protocols that allow ASCOM to go out to the Mac and to Linux. And I'll give you a lot more detail on that in just a sec. So back in the old days when I started off on all this is kind of what we had. It was everything connecting to everything else. I'm just double checking here, Alex, to make sure that's that rat's nest of wires is what's showing for everyone, right?
Correct.
Okay.
You're good, Bob. You sound good, and the picture's coming through fine.
Excellent. Okay. So this is what we had for a long time, in not only with the actual wiring, but also every device had its own little protocol, and every program had to implement that protocol, and everything was talking to everything else. So if you wanted to, the old question was, which telescopes do you support? That was a bad deal because every time somebody came out with a new mount, then everybody who had software that supported telescopes has to write special code for that mount. And that was just ugly. That's what I call the Wild West. It's still that way right now with cameras, and I can talk about that after this presentation. I don't want to spend too much time on cameras because, especially with SCMOS, things are really in flux right now, and there's a lot of stuff going on, and it's kind of back to the way it was in 2000 for everything else. Cameras have they got better and then they got worse again. So we'll get to that in a minute. Plus there's new applications for it. But I want to get into some of the stuff that is done and is ready and has been done and is working, which is pretty much everything but cameras. So in the beginning, it looked kind of like this. And what I'm going to talk about tonight is ASCOM Alpaca, which is a technology that takes the Windows common platform for everything talking to each other, so that a planetarium can be written, and as long as it speaks Alpaca and can talk to any mount that's out there, including anyone that comes on the market after the planetarium's written, and can talk to that as well without any modifications. So now what Alpaca does is it extends that common platform, that infrastructure, the ecosystem's a better word, to Linux, iOS, Android, and the Mac. And it does that with a technology called REST API, and I'm not going to get into the bowels of that on this presentation, but suffice it to say that it works over the internet or internet connections. And by the way, an internet link can occur inside the same Mac or Linux or PC or Raspberry Pi or whatever that thing might be from one device to another. So it doesn't mean that you've got to have Wi-Fi or Ethernet or anything. It can go from one program to another or one device to another within the same box. But it's still TCP/IP and REST API. And I'm not, as I say, I'm not going to get into what REST API is and too much more detail. I'll answer questions later, and if it gets too technical, we'll go offline, and I'll give you a call, or you can get on and chat with me or whatever later after the show. So let me go a little bit more detail into what ASCOM standards actually are. It's all about plug and play. I was trying to allude to that earlier. The idea is that a program, SGP, let's say, can talk to all different kinds of focusers or mounts or domes, and they don't have to write special code for each one of those. If they had, it would be tough. Recently, I know they've done some of that for cameras. I've had a discussion with them. They don't like having to do it. I think it's prolonging the agony, and so that's one thing. But for everything else, they don't have to do anything, and neither does people doing planetariums or anything else. So it's all about plug and play. And the way this all works is with objects and actions, and they're a standard set of objects and actions in ASCOM. The objects are things like right ascension, declination, focus count, exposure duration. Those are things that the spelling of them, the actual words that you use in the code that you write, are the same everywhere. So that's the standard. It's a standard interface. And then the actions are things like slew or expose or open shutter. Those words and actions are standardized, and the ASCOM standards are those names for the objects and actions. They also define the behavior of each one of those things. So if you ask for the RA, you should get it back in hours. If you ask for a slew, it should start the slew and then come back to you. And then you should be able to ask for the object slewing and to see if it's still slewing. And you just keep asking that every few 5-10 seconds until you see that slewing go from true to false. Now you know the slew is completed. That would be the same for every mount out there. And that's the key. It's 5 minutes or more. How am I doing? You wanted me to stop every...
We don't have any questions yet related to the topic. So, and you are doing fine. So just keep going. Everything's running.
Okay. That was my 5 minute stop, or more than 5 minutes,
well,
I guess.
Just every once in a while, stop by to make sure that YouTube hasn't done something nasty.
Okay. I can't see right now the chat because I'm looking at my presenter notes and the browser's behind that. So right. I'm sorry.
If something comes up that we think we need to interrupt,
let me see if I can shuffle things around here. Just a sec.
Okay.
I got them shuffled around now to where I can see that stuff.
Okay.
Hi, Adam. Hello, Adam. Adam, by the way, deserves some thanks from me for allowing me to take the first 20 minutes of his time at the Northeast Astro Imaging Conference 2 weeks ago, something like that. Yeah. He had the opening presentation on the Friday of NEAIC, and Adam gave up the first 20 minutes of his time for me to give this presentation there. Adam, thank you very, very much. That is most appreciated. So where was I? Oh, yeah. Besides the objects and the actions, the other thing that the ASCOM standards specify are the defined behavior. It has to act a certain way. And if you have all these things, the words, the nouns and verbs, or objects and actions, and the behaviors standardized, and if you conform to that, then I can write software without ever having to have a copy, one of your mounts or your focusers. I can write software and it will work with your mount as long as it conforms. I don't have to test or anything. You can plug a brand new focuser into my program, my focus program, and it will work if your focuser implements those standards. And that's the magic of ASCOM. That's why it's really cool. And the other thing I need to point out is that the standards cover routine operations, and this is really, really important. It does not cover engineering things. So you will not see things like motor currents, biases, encoder ticks, PE counts, periodic error counts, or that kind of thing, because that's what, or even pointing correctors, you won't see that, mount models and that sort of thing, because that's inside the device to make it work more perfectly. Think of it this way. If you have a mount and it's a perfect mount, then when you tell it to slew, it will slew instantaneously and point exactly to the RA and deck you tell it, and it will track absolutely perfectly with the sky. That would be a perfect mount. So that's what ASCOM gives you access to, slewing and tracking. I'm highly simplifying it. What it doesn't give you access to is, well, when I'm pointing, towards the east, I need more motor current because my mount drags and blah, blah, none of that. That has to be whatever it takes inside the mount to make it more perfect. That's all part of the mount stuff itself. And that's not in the ASCOM standards for any of the devices. So the key is routine operations. And it's very hard to negotiate standards under those conditions because everyone wants their little magic Hammerfraz Wiebelfetter thingamajig to be exposed because it makes their thing look better than the next one. But actually, what makes it look really better is when it does what it's supposed to do better, and not that it has some clever thing in there that makes it better than it would be without it. If you can follow my logic, I'm not sure you can. But anyway, I'm not going to belabor that anymore. Routine operations only. That's ASCOM standards. So how did we get here? As I said, in the old days, we had no standards. The app developers were having to support incompatible devices. I don't want to talk like death by PowerPoint, so I'm just going to let you read while I'm explaining this. And then when ASCOM came along, it kind of put everybody into a common ecosystem. It took a while to do, but it has worked. And by and large, that's the way things are now. Now, what Alpaca is doing from here is it's taking those same standard nouns and verbs, exactly the same, and the same behaviors, and just turning them into internet calls instead of calls over COM. So it's easy to think of ASCOM as Windows only COM. It only works on Windows. It's COM based, blah, blah, blah. Well, what Alpaca does is it takes those same abstract interfaces, the same nouns and verbs, and it applies them over the internet. And so now any platform can talk to any other platform using that same set of nouns and verbs. And the key here is that set of nouns and verbs is the number one highest risk part of designing any distributed system. So if you get that right, then you can move it from platform to platform or environment to environment, and it will survive. If you start out with a bad interface, you have a tough time going forward. Well, the ASCOM interfaces have been proven over the last 20 years to be right. They work. They work for what they were designed for. They work, and there have been some minor mods over the years, not very many, additions mostly, additions, but they're there. And so we're taking the same set of calls and moving them out beyond Windows and using the internet to spread them. I hope that makes sense. So this is kind of I hope everybody can see all of this. There's nothing too small in here, right? I mean, I don't expect you to read the title bar on Carte du Ciel over in the lower left. But
no, you're going good, Bob. That's
okay.
Fine.
So let's get a little more concrete about that. The ASCOM. I wish I could. Can you see my my mouse? Is that possible?
Yeah, yes. You're pointing up towards whatever that planetarium.
The sky. That's the sky over there.
Yeah.
Okay, so this is good. All right. So in the ASCOM world over here on the left, we're on Windows. This is the little ASCOM logo. To talk from the sky to a planet to a mount like this, the sky would be making its standard ASCOM calls and going through COM on Windows, and then there's a driver here that for that particular mount translates the standard nouns and verbs into whatever gibberish this mount needs to do its job. That's the key. So there are the pieces on Windows. Now, the key to what makes Alpaca workable is this thing here in the middle. This is called ASCOM Remote, and it is a development by a guy named Peter Simpson, who has been doing all of the heavy lifting for ASCOM for a while now, and it's brilliant. So what this does is it gives you a driver for the sky that looks just like any other telescope driver, only instead of going through COM, it goes out over the internet. So the sky, instead of selecting the astrophysics or whatever that looks like an AP mount, you'd select ASCOM Remote 1. Well, for a focuser. Let's say this guy wants to connect to this focuser over here. This is an Optech Focus Links, which, by the way, already has Alpaca in it. So you want to connect to this focuser. The sky can go out through ASCOM Remote, through Alpaca, and connect to this focuser, which is a Wi-Fi focuser, no USB even. And the sky is totally unmodified. No changes need to be made to the sky at all. It looks like it's talking to a focuser connected to the Windows machine. But by virtue of ASCOM Remote, it gets converted from COM to Alpaca, which is this REST API. It goes out through the internet and uses this focuser. As an exercise last fall, I wrote a rotator simulator in Python and put it on a Raspberry Pi, and I have a video. It's on the ASCOM website, which I'll show you later, that'll show you where you can turn the field of view indicator in the sky, and it turns the rotator simulator. And so, again, the sky is totally unmodified. So the trick to this whole thing to making it incrementally work is ASCOM Remote. It also works the other way. A couple of weeks ago, we learned that Patrick Chevalier has put Alpaca compatibility into his Carte du Ciel planetarium, which runs on I better put my mouse over here. Carte du Ciel, which runs on Linux and Mac, and also Windows. And it can use a mount that's connected to a Windows machine. So some of the mounts don't have Linux drivers, ASCOM drivers, let's say. So now, and he will tell you that ASCOM he prefers over INDY, and we'll not get into INDY on this. Again, that's another thing I can talk to people about. It's totally different from ASCOM in its philosophy and application. And you don't need servers with Alpaca. It's all point to point. So anyway.
Okay.
So
Bob,
yes, sir.
Can I stop you? Is this a good point, or you want to finish something?
No, this is great.
Okay. I asked, well, let's start with Tolga's question down here at the bottom, because I think that answers a lot of stuff. Where is Alpaca installed? Where is Alpaca? Is it like
it is not installed? The ASCOM Remote would be installed on a Windows machine, and that is the middleware or gateway between this thing here, that's installed on Windows, and it forms a gateway between the current Windows COM-based thing and the entire internet. But there's no Alpaca that gets installed outside because it's just a protocol over internet. That's it. So if you want to talk to a focuser, the focuser itself has to implement Alpaca inside of it. Or if it's on a Linux machine and the focuser's plugged into one of the Linux machine's COM ports, let's say, or a USB port or whatever, then there needs to be an Alpaca speaking driver on the Linux machine that can receive that there is no Alpaca to install.
Okay, it's the device manufacturer has to incorporate Alpaca in their commands.
Or furnish a driver, just like they do on Windows now. If you build a mount, you've got to supply a driver, and that driver speaks COM. If it's on Windows, you could develop a driver that speaks Alpaca on Windows, but it wouldn't really. You don't really have to, because if you have a COM driver on Windows, ASCOM Remote provides an Alpaca driver for you. It will convert your COM driver into an Alpaca driver. So in the case of Cart2CL, he's using the Windows COM driver for the AP, but he's speaking Alpaca to the Windows machine, and then ASCOM remote converts that and talks to the mount for this planetarium here. So as you can see, it's not just a dream. It's a chicken and egg problem. I know we've got the chickens. Now we just need more eggs,
Okay.
if you want to put
Now,
it that way.
well, there's a series of questions that are related somewhat to the same thing.
Okay.
I see the Windows emblem over there, and I see a Mac emblem over on the other side. Do you have to have a Windows machine in this mix to get this to work?
No, and I'm going to cover that.
Okay.
Actually, right in the next slide.
Okay, well then we'll hold off on that and a few of the other questions from Elmiko.
Now, there's no, you could easily, for example, if Cart2CL could use a focuser, I'm not sure it can, it could talk directly to this Focus Links focuser through Alpaca and then not even have a Windows machine. There's no need for a Windows machine, and I'll stress that in just a minute.
And so if you know how we hear that there aren't that many applications for astroimaging in the Mac world, does this make it a lot easier for Mac people to write applications?
I think it does, and you know why? If they let me put it this way: Cart2CL being a planetarium and running on the Mac, it took Patrick Chevali 4 days to add Alpaca capability to his planetarium. So now on the Mac, he has access to any telescope, EQ mod, plane wave PWI, astrophysics, AP, APCC, all of the mounts that have control systems that run on Windows. Boom, they're right now today accessible to a software program running on the Mac. So now, if you are somebody who wants to write an imaging application on the Mac, or it's in some kind of an astronomy application, and you are looking at how the hell you're going to control all these mounts, and well, you know, I've got to put all this XYZZY BS in here. We're back to the Wild West again, right? Because there's no driver architecture for the Mac. And I could, if somebody wants to know why that never happened, I can answer that, but this is not the right time. Okay. There isn't. Let's put it that way.
No. And you've several times said something about that, and it over the internet, and it does this and that. The internet's not required to run any of this. I can actually just run it from my desktop computer that's running my rig and just tell it to go do this stuff, right?
Well, you need some kind of a internet TCP/IP type connection. It doesn't have to go out over the public internet. In fact, I would say running stuff over the public internet's really a bad idea, because it's kind of really like, you know, it's a hostile environment. Let's put it that way. Okay. But going from your I don't know what your rig is, but you know, the TCP/IP can run from between one program and the other on the same machine. I was sort of pointing that out before. So you don't need the internet. If you're going to run everything off of one box, Alpaca will still work, because the imaging app will speak Alpaca, go through the internet, the TCP/IP layer in the operating system, pop up into another program which is acting as a driver for the mount, let's say, and the two of them are talking over TCP/IP, but with the same, you know, 127.0.0.1 internet address, and you're just using that as an inter-process communication scheme, and that works just fine.
Okay, let's see the next couple of slides, and then we're going to get back to Linda's question, which I think will be, we need the next couple of slides for.
Okay, so what the next slide is ASCOM Alpaca, not just for Windows anymore, which is kind of the title of the talk. This is what I had showed you before about it providing the interconnections. Notice the arrows do not all radiate out from Windows to Linux, Windows to iOS, Windows to Android, Windows to Mac. No, there's arrows between Mac and Linux. There's arrows between Android and Linux. There's arrows between them all. So the whole point here is you can just ditch Windows, and that's all still Alpaca. So to answer your question, and everybody asks the same questions, why, does this need it Windows? No, it does not. But the route into Windows is that ASCOM remote, and this is the guy that's responsible for it, and he's also responsible for doing all the heavy lifting on the existing ASCOM platform. He's a key person and very underappreciated. He operates in the background. He's a former software engineer, career software engineer in the UK. His thinking is brilliant. He really gets it, and he is my best ally. We work so well together because both of us have similar career backgrounds, and we understand our architectural issues really well, and we never argue about stuff. I mean, there's the fundamentals are timeless and have been around for 30 or 40 years, and so we communicate very well, and he just loves what he does. So we should all give Peter Simpson a round of applause. Now, with that, I'm going to go to this thing and ask for more questions, because I think there probably are, and then I can back up to some other of the slides and maybe fill in some of the gaps that sounds like I've left. Did you have some other questions?
Oh, you want to ask
more about Windows,
or do you want to go? Okay, let's go to
you said something about Windows.
Yeah. Linda's got a question. Is one of the goals for this to decomify the ASCOM driver so cross platforms can be easily written by the manufacturers? In other words, it isn't dependent so much on the COM ports, I think.
Well, there's a difference between COM ports and COM, which is the inter-process communication system on Windows. Those two aren't the same thing.
Well, that may be what Linda meant, and I screwed up and then translated it to
you. Let me try and bring that question up myself just to see.
Yeah, it was asked at 1853.
I am not seeing
my time.
That's that thing. I don't have apparently the chat open anymore. I thought I had minimized it, but instead the Rumble chat has somehow disappeared. So
okay,
I'm hoping like hell. And now I actually have two browsers open with the same thing on it, which is not good. What? How can that be? Well, all right. I'm just going to keep going here.
Bob, I pasted that question in the internal chat, if you can see that.
Okay, I see it. So this is a discussion that is underway right now, but the goal of ASCOM is not, of Alpaca, is not to produce a cross-platform development kit. This got into a big discussion, and that's beyond the scope of what this is for. What this is for is to permit cross-platform operation between clients and drivers, and to open up the ecosystem so that programs on one thing can talk to devices on another. If somebody wants to write a single driver that runs on 3 different platforms, that is very difficult, especially with Linux, because there are how many types of Linux out there? You tell me how many flavors or distros there are out there, and how much if-defs you have to put in your code to do it. Okay, well then you write it in Python. That's good, fine. Python's probably a good cross-platform thing for all of this. If you wanted to do that, I would probably write the whole thing in Python. Yes, you could write a device driver for a mount in Windows in Python, but you have a little problem with GUI. What the hell do you do for a GUI on Windows? And on Linux, you've got 5 different GUIs. What do you do there? How do you write that? And on the Mac, that doesn't port over. You can use Qt, which is what the Sky is written in, and that's really nice. It's a C++ type of environment, and it works. You could do that today. You could write a driver in Qt that would run on Windows, Mac, and Linux, and you could speak Alpaca and it would work on Windows. Yes. So, but that's not a goal. So it's possible. I'm saying this opens up the possibility of that, but producing cross-platform development tools is not part of this effort. Does that answer your question?
Linda will come in with another question if if that didn't answer her question.
Toga, though, did that answer yours?
Oh,
No, that was not my question. I was just relaying.
Oh,
Linda's
this was
question.
somebody else's
yeah,
question.
it came from
All
Linda,
right,
but
all right.
it was, for those of
Okay.
you who are out there, remember, we've got two different chats going on, as well as two different viewers and things like that. So it gets a little confusing here, and we can see some things and we can't see other things. And
I
so,
lost my Rumble
yeah.
chat. I'm sorry. I would wish I
And-
could see it now.
okay. Almico
I
asks.
do have a question, Bob.
Sure.
Or if you want, we can throw this question in the back of your presentation. But my question is about ACP. Like, how does this help ACP, or what's the future with ACP with this? But we can throw that on the back of the presentation.
ACP doesn't change. It runs on Windows, and by virtue of ASCOM Remote, ACP has access to everything out there on all the other platforms. All I do is speak the COM language I speak today, which is all built into all the pieces of ACP, and you just pull up the chooser and select one of the remote devices, and I speak to it exactly the same. It doesn't have to change, and neither does any other Windows software have to change to have access to devices on other platforms, and vice versa. Programs on other platforms, by adding Alpaca, can go backwards or the other direction through ASCOM Remote. And what I should do now is to go back and bring up this magic slide, which let me back this up. And come on, baby. 2, 3, 4. Would that do it? It's kind of slow here. Just a sec. One more. Okay. So can you see this okay?
Uh-huh.
So this could be ACP. And I could still talk to the Focus Links focuser without changing a thing. The point being, ASCOM Remote allows Windows applications that are speaking today's COM-based, that is, COM, not COM port-based, but COM, component object model, which is an inter-process communication scheme on Windows. Language independent, which makes it really cool. I can speak that just like I do today, and instead of directly selecting this mount, I could select out here, go through ASCOM Remote, and come out to a mount that has a Wi-Fi processor inside the mount that speaks Alpaca and is sitting out there with no wires hooked into it except for power and Wi-Fi. And I could talk to that mount and move it around just like I move any other mount. So that's the magic here, is ASCOM Remote, and the fact that all of this, the Alpaca protocols are all pretty much language independent, because REST and JSON, which are the two technologies in there, are implemented in virtually every language on every platform. So it's a matter of implementing the interfaces and then hooking them into your logic, and boom, you've got a new device that people can talk to from other platforms and also Windows through ASCOM Remote. So it's hard to kind of get the idea of what the significance of ASCOM Remote is, but this is the key to making the ecosystem grow without having to redo stuff that's already out there. And that was the key. What's out there on Windows right now will be extended out into the expanded ecosystem without having to be changed. Of course, you can change it if you want. If you want to write a cross-platform program, which Patrick Chevalier's done with Cart2CL, sure, there's nothing to stop you. But we're not going to force people on Windows to ditch what they have now and start speaking this new protocol and using this new technology. They can continue to operate. And for things like PWI, for PlaneWave and all of that, they have loads of money put into that, and it's really complex and very sophisticated. And they, that now is available to applications on the other platforms.
Okay, Bob, I think you probably answered this question, but Miko, will all our existing gear still work the same if we are using Windows? And will Alpaca be required for us?
The first question, yes. All through the history of ASCOM, there has been no incidents of ASCOM itself becoming incompatible. So it's really been focused on to make any changes to ASCOM not be breaking changes to what's already there. So no, it does not affect the current Windows devices at all. You put ASCOM remote on there and it gives you some more stuff that you can select as devices.
My equipment's all set up out in my observatory and everything's happy and everything. I will never notice Alpaca until I buy a new focuser or a new something, and then all I have to do is make sure I use the chooser.
Correct.
Okay. Alex Barakin asks, is it possible for Alpaca to talk to INDY devices? And before you go off on that one, YouTube user has asked, how is it different from INDY, which is existing standard, which started on Linux but is now available for other platforms too? Maybe if you could talk to that.
Well, somebody will probably develop an INDY to ASCOM gateway of some kind, but INDY is how's the best way for me to, let me put myself back on the screen because my facial expressions are going to be just as important as anything else. Just a sec. Let me bring this back up. Where am I here now? There. Unscreen share. There we go. Of course, I would have to cough as soon as I get on screen. So INDY was developed by Elwood Downey back in the 90s for school back in Ohio, University of Ohio, I think. And it has become a standard on Linux. Well, it was a standard on Linux. INDY is Instrument Neutral Device Interface, INDI. What makes it instrument neutral is it is a standard which allows you to discover what the device is and what it can do. So basically, it's a standard for describing standards, so to speak. It's hard for me, if you guys aren't into software architecture, this is really pretty arcane. But the fundamental difference between INDY and ASCOM is that ASCOM standardizes those nouns and verbs to just that set for that type of device and the behaviors. INDY allows you to add stuff. You can put more things in, and then you can go out and discover it. Elwood's original idea with this was to be able to self-describe devices and have code that would actually build a user interface to talk to all of the features of that device. If you think about that, it would allow I don't know if you can kind of get what I'm trying to what I'm driving at here, but the two types of standards are not, they're two different types of standards. I'm not saying INDY's bad, but if you have a device that has features in INDY that aren't in ASCOM, they're not going to show. And then you're going to go, ASCOM sucks because it doesn't have the VBL double wham and flapper. And what do? ASCOM specifically keeps that stuff out of the interfaces, and that's fundamental. And so, and also from a plumbing standpoint, in order to go between devices, INDY needs servers, and you have to be able to daisy chain servers, and it runs on XML, which is like some pretty crufty old stuff. And so, it's out there and people are using it, and I'm not saying it's bad, but it's not something that it doesn't really fit. It's a square peg in a round hole with ASCOM. I know that's not a very good answer if you're not a technical person, but it's the best I can do right now. Sorry.
Okay, where are we on these questions here? All existing gear. Yeah, there was coming up on where did it go? Does this seem like there wouldn't be much incentive left to produce drivers on non-Windows platforms? Would this just detract from that?
Oh, no. In fact, I think the biggest, personally, I think the biggest attraction is to put drivers inside the device themselves. So how neat would it be to have a rotator sitting on your scope that has Wi-Fi in it? And there it all is. You've got the mechanics, and then the driver right there in the thing, and what you see is an ASCOM interface looking into it. Alpaca flavor ASCOM interface looking right into the device. So the driver and the firmware and the mechanics is all in one little box. That's cool. And you could do that with a mount, focuser. You could do it with a camera, but trust me, the camera issues right now, especially with what do you do with a CMOS camera that produces 32 gigabytes of data in order to get one 50-second image, which you have to stack at the other end. That's a whole different issue, and you can't pipe that stuff across the internet. In fact, it's hard to even do plugged into the same computer. So that's a different issue. But for a CCD camera, which is a still image, and the ASCOM camera interface is still image. It's designed for still images. So one image, you go click for 50 seconds or 5 minutes or 10 minutes or whatever, clack, and then back comes one image. That's practical. And so that could be done without an issue over Alpaca, because Ethernet's fast enough for that.
Excuse me. One of our watchers, Linda, points out that it would be great to see Alpaca supported directly in the Wi-Fi capable devices. Scuba Bry asks if he can run ACP 100% remote to all Alpaca connected devices.
You could. I don't know how I don't know where I could find a mount right now that. Maybe let me think about the true meaning of that question. No. Well, okay. Technically, you could. In other words, I think what you're asking, and I wish I could see that Rumble chat thing. I'm sorry I closed that.
I'll just
thing.
Scuba Bry just asked, can I run ACP 100% remote to Alpaca connected devices? And I will paste that.
I think I'll be able to answer the question. Yes, in theory, you could. In other words, ACP could run in your house, and you could have your mount, your dome, your focuser, your camera, your rotator, all of that stuff out in the observatory 1,000 miles away. And yes, you could do that. Should you or would you ever want to do that? No. And the reason is the public internet is a very hostile environment. The ASCOM and the Alpaca does not include things like secure sockets layer and high strength encryption, authentication from something other than ACP or HTTP basic authentication. You should have things. What you would do if you were going to do that is put an Apache proxy server between your devices and the public internet, and another one between your intranet and the public internet. Now you've got a really complicated setup with the low-level device commands going 1,000 miles over the internet. That's from a distributed system design standpoint, that's really bad. I mean, it's just a poor design. You put a box out there that costs next to nothing and you control it with some low bandwidth thing like a little ASCOM, a web form where you fill in, the target name, RA deck, and the position angle and the filter you want and the binning, and you push a button. And then you let the $200 computer out there in the observatory manage all the devices and acquire all those images and throw them in a Dropbox, and you get that stuff back. That's a better block diagram design than trying to run your I miles away from the devices. I think I've answered your question. I would never design a system like that.
Alex Verikin asks, so instead of USB hub, we need to bring networking router to the field?
If you have Wi-Fi, no. Let me think about this. What do you mean router? The router would be for if you were going to pipe anything over the public internet, right? So with Wi-Fi, you would just, oh, I see. Okay, so if you had all your devices on Wi-Fi, yeah, or if you have them on Ethernet, then you would need an Ethernet switch. You know you know what I'm talking about, the thing that has 8 little Ethernet sockets in the back. They're like $25. That you would need something like that.
But for most of us, basically, we're just going to continue plugging in USB cables to our various devices. And if their driver is an Alpaca type driver, they'll use that instead of whatever they had been using.
Well, they can still, if they're plugging it into the USB of a Windows machine, they can use the driver they're using right now.
Right. Okay.
That doesn't have to change. If it's plugged into the USB port of a Raspberry Pi, then maybe you have a little Python-based Alpaca driver in the Raspberry Pi, and then that thing, uses the GPIO pins to turn the motor and do all that kind of stuff. And I don't know, however you want to do this. I mean, it opens up the ecosystem to doing things with more flexibility and more possibilities of how things are designed. And that's really the whole point of this.
Okay. Tolga, I think we've got through all the questions that are in Rumble Talk.
Yeah, I think so.
Cool there. Anybody else got any questions? And you don't have to limit it to Alpaca. Bob, you had another slide you left us with about what we should be doing.
Well, there's a couple. Yeah. Let me do that again. Let me go
let's
back,
get back
here to that.
Don't forget, everybody who's out there, go ahead. If you've got questions, go ahead and type them in and we'll get them.
Please
they don't
ask
have
more
to be limited
questions.
to just Alpaca.
I know it's Easter evening, and we probably don't have as many people as usual. But hopefully, it will be. It'll be available out there after tonight, and other people can look at it. So, if you have questions, or if I didn't answer a question for you the right way, sometimes it's hard to interpret questions. So, if I answered the wrong question, or if you think I glossed over something, the two things I'm going to gloss over is INDY versus ASCOM, and what do you do about cameras, CMOS cameras? I'm going to gloss over that, and both of those are still, well, the first one's not even a question. The second one is it's open, it's in flux right now, and I will talk about that actually after we're wrapped up, because I have some very strong feelings about it, which is grating against the camera manufacturers right now. So hang on. Let me get myself back to the slide where I was. And remember, you can get rid of Windows and this all still works. So just so that you remember that. And there's Mr. Peter. All right. So what's next? How can you help as an ordinary user? And this is one of my crusades right now. First of all, the whole purpose of a standard like this, and I will say this has been the way it has been in the rest of computing for 40 years. That is the driver versus the client. No, the driver and the client. So by having a standard between the printer and the word processor, for example, when the printer malfunctions, we know where to go. If the word processor had a bunch of code for controlling the printer, and then the printer malfunctions, where do we go? The word processor? Is that where the problem is? Or is the problem in the printer? So by having the standard, we're able to figure out who to go to. The corollary to that is, if you have a problem with something, go to the people you paid the money for, that you paid the money to for that device. I just was looking at one today on the ASCOM site. The guy gets on there, well, I can't figure out how to use this Celestron focuser, and what driver do I use? And I went to the ASCOM website. No. What about calling Celestron? You paid him money for that thing. How do I connect to your focuser from my focus program? And if they don't ever hear from people asking that question, they'll never get it. And so we let manufacturers get away with so much just because we've been a garage shop hobby for so long and we put up with all kinds of stuff, but man, we pay big money to people for stuff and then it doesn't work and we go out to the community and you know how that is. You get all kinds of advice from people, old wives' tales. Well, Uncle Festus told me if you beat it with a hammer, it'll run faster and stuff like that. Instead of going to the manufacturer that you got the thing from and go, hey, I have this program. I tried to connect to it. It was listed in my chooser, you know, the XYZ focuser, and I selected that. I pressed properties and I set all the settings, but it won't connect. What the hell? Go to the people you paid the money to. And if they don't answer, then I'd say you write them a note and say, you know what? I can't use this thing. It doesn't work. So give me my money back. If we would just take that approach to life with astronomy things, we would save ourselves and the hobby and the industry so much pain. But, you know, we get somebody, well, anyway, that's a whole nother soapbox discussion. I don't need to get too much further, but that's what I mean by insist that the apps and the devices you buy be broadly compatible. So you have the most flexibility and adaptability. That, again, means if they have an ASCOM or an Alpaca driver, that gives you all kinds of flexibility. You can talk to it from different software. The developers can go develop software and know that without having to go to somebody like a camera manufacturer or a focuser manufacturer with a tin cup in their hand and go, can I get one of your things so that I can develop the special secret sauce you require for me to be able to give this flex capability to my customers with my app? And that's going on with cameras right now. And anyway, I could get really wound up about this. Finally, the last one is the most important. Give it time, because we have chickens and we need eggs. It's going to take time. I'm sensitive to the device makers. Optech jumped on this thing right away as soon as they saw it, and they already have one device that is natively Alpaca compatible, Alpaca, and they're doing it for everything pretty much, except their Windows things, which will remain on COM. So give it time. Don't run into people with pitchforks and torches and say, we want Alpaca. It wouldn't really do that much good. So that's it for the Alpaca part of this. Maybe. I am happy to answer more questions or go into more detail. I'm hoping that somebody out there will have, some questions, more questions, because I love answering them.
We were asking questions all the way along. Now, Miko, his point is that, so the whole point is that ASCOM will now work with Mac and Android, not just Windows.
That's correct. The ASCOM, the standardized nouns, verbs, and behaviors. That's what ASCOM really is. And actually, I should say something here. I see a lot of posts on, places like Cloudy Night. ASCOM sucks. Every time I plug my thing into my thing, it blows up. Well, just to put things into perspective, ASCOM is a spec, the specification. The ASCOM platform, which you install, is a set of libraries and verification tools and the chooser and some other pieces that a driver writer can use to provide access to their device. They're just modules, and those modules have a lot of miles on them. They are rock solid. First, they were developed by people, not just Peter, but few other people who are very good developers. They also have a lot of time on them, millions of miles and years and years. So it's not going to blow up in the ASCOM libraries. Where these things blow up is in the actual driver that the person writes to support their brand new rotator or whatever. When that blows up, people blame ASCOM. No, that's not what is. There is no ASCOM. That's not a program. It's a spec with some libraries. So I need to point that out.
Okay, thank you. We have one question, and this happens occasionally, Bob, so I'm going to give you a break for a minute. Who was it that was asking? Tadej was asking about a driver for his camera it's a 350, Canon 350, and he wants to know which software to use for image acquisition. You may or may not be aware of the history, Tadej, of Canons, but I suspect that what you've got here is one of the pre-USB controlled Canons. That is, it has a USB cord going out to it, but that USB cord is only for downloading the information after it's been taking a picture. And if in the olden days, back when I first was doing DSLRs, you also needed a control for the shutter itself. And that was a separate wire that went out to the camera and went into a separate port on the side of the camera. And it's kind of like the remote shutter port. And you needed a USB, a device that plugged into a USB port on your computer to tell that when to trigger. Okay, now I believe the 350 was probably in that group, and that's why you're having a problem, because since then people have moved on and they use a different kind. Now, I think in backyard EOS, or maybe I'm wrong, but I think in backyard EOS, there is a choice for the older system of doing this and the newer system of doing this, the Canon connections. And I think if you use backyard EOS with the older system, I think you might find what you need. But I think I might be wrong also. So don't take my word for it. But ask your questions about that. Linda, Bob, can you go into more? Okay, Linda has just asked another question for Bob.
I want to get this this Rumble chat thing back. Hang on.
Okay.
If I put in the
Why don't
astro
you do that?
imaging,
I want to check something here. Tom, can you hear me? And can you unmute yourself? Can we unmute him? I don't seem to have the unmute button for him.
all right,
Can you
watch
unmute
live.
him, Tolga? There we go. Tom,
I
can
got
you say
that.
something? Can you unmute yourself? Yeah, can
You hear me?
Is that Tom?
Yep.
Yeah.
Hi, Tom. So you're speaking. While Bob is trying to figure out Rumble Talk, can you
Okay,
tell us what we're going to hear about next week a little bit?
Sure. We're going to cover high resolution imaging using CCD video cameras to capture high resolution images of the solar system bodies. And I'll do some processing, demonstrate the various freeware that's being used. And we'll process an image of Mars and maybe some other planets if I get a chance to take some more captures between now and next week.
Okay. Thank you very
That
much.
sounds great.
So come on back. Now, Bob, you have access to your Rumble Talk, or would you like me to repeat?
I do. I got it going again. So this is good. Let me, okay. And I have myself on the screen. Hello again. And the Rumble Talk's right in front of me. So I'm in good shape. Tom, in fact, this is one of the things that comes up with regards to cameras and ASCOM and the application. Effectively, these cameras that are producing frames at a high rate and you're processing those into planetary images. This is not a design objective for the ASCOM camera interface. There are ASCOM video and video frame interfaces out there. As far as I know, no one's using them, but they are there. And if a camera were to implement those could deliver the video stream, the frame streams that you need in order to do the planetary imaging that you're doing. So there's just to make a comment there, the ASCOM camera interface is not designed for that. It's designed for still imaging. Click, 10 minutes later, clack, and you download an image. So that's its mission in life.
Right.
Can I go?
Telling us what's happening next week while you were getting ready there.
Oh, sorry.
That's okay. No, that's fine.
I thought you were asking me to respond to Linda.
Yeah, you're responding to. Does that respond to Linda? Can you get more into the camera?
That's one of the driver issues that I had planned on covering. Yeah,
okay,
actually.
Okay.
So first, the ASCOM camera interface is for still imaging. There is another video and video frame, a pair of interfaces for planetary and that type of work. Also, that's used in space situational awareness, SSA, junk tracking, that kind of things. where they look for scintillation and rapid fluctuations of things and so forth. Anyway, other camera issues. Were you going to ask? I think I just stepped up somebody.
Linda, have we covered your questions?
I'm not
It
finished.
took Linda a couple of seconds to get something typed in if she's typing something in.
I haven't finished answering
okay.
her.
Okay, go ahead.
What are the chances of ASCOM supporting bias in the camera driver? That's a big one, and that's been the real. Well, there are two big issues: bias and good. Okay, Linda, I got you. Bias and also the stacking. The bias comes up with CMOS, and if it turns out that bias is something that should be in the interface, it will go in. And so to answer your question directly, there have been additions to the interfaces over the years for this kind of thing. However, I just came back from NEAIC and I talked to FLI and SBIG, both of whom say that bias, while it's cute that it comes out, that it's out there and needs to, that it's available from the Chinese CMOS cameras, that they really don't want that out there because it's more of an installation setting for the specific sensors or that they've put into the camera. It's an adjustment, a factory adjustment, and they want to be able to have that adapt and not be a setting because it's too easy for people to adjust it into a place where it actually greatly reduces the dynamic range of the camera. It just looks like you're doing something more. And I don't know anything about this. I know absolutely nothing about cameras. I am talking to the chief engineers for SBIG and FLI, and they're saying we don't want bias out there because we don't need it for our SCMOS cameras. We don't need it to be out there, and we just would rather not get into all of that. Now, the other thing, but if it turns out that that's wrong, and let me put it this way: the users won't drive this. Probably they'll ask for it, but then you'll always find people who want the mixture control and the spark control on the dashboard of their car too, because that's really cool, right? But maybe that's not such a great idea, and the car manufacturers are not going to want that to go out there if they can avoid it, because you can also, by messing with the spark, you can also damage the engine. So what I'm trying to say is that, that whether or not that is going to work or not, what I'm hearing from the experts, and somebody lashed out at me for being, well, what do the experts know? Who are these experts? Well, they're the guys that engineer the cameras. FLI and SBIG were the two that I talked to. So, and I have not talked to Chambers yet from Addix / QSI, and I intend to talk to him and get his input, but I'm not going to drive that spec. I'm not going to be involved in it. I'm just bringing you what I know from the discussions, and I'm just stirring the pot right now on that. So maybe it'll go in, maybe it won't. I don't know the answer to that. The other thing, which I do know, which I've gotten from some of my customers, several of them, and they're really vocal about it, is they want that stacking to be done inside the camera. And boy, when one guy has an SCMOS camera, he's taken 50-second exposures. It's a 4K camera. He's taken 100 millisecond subs, and yikes. That's 32 gig, 16 or 32. But it's a lot of gigs, 16 gigs of data for one 50-second image. So really, and he doesn't need the individual frames. He doesn't even want them. He doesn't want to have to deal with them. So he wants a camera where he goes click, click, 50 seconds later and gets an image back. That's the functionality he's looking for. But he wants the high dynamic range, which you get by stacking a bunch of short exposures and adding them all up. So that's what's driving it. What will need to go in and is almost certainly going to go into the ASCOM camera interface spec is a sub-exposure interval. So if you're taking a 50-second exposure, how short do you want the subs to be? So you want this to be, let's say 1 second exposures. Well, now you'll be stacking 50 of them before you get your thing back. oh, well, what about star matching and all of that when you're stacking? You could do that, which would effectively mitigate tracking errors, but you don't get that in a CCD camera anyway. So I don't know. Again, I'm no expert. I think you can just stack the images inside the camera and be done with it. And but I don't know for sure. So those are the two issues that I see for cameras right now is onboard stacking. Oh, I should point out in the old days, I'm sure some of you remember this, when the CCD cameras came out, they didn't have buffers in them, and you'd plug them into your DOS machine, and then when it came time to read the image off the chip, it had to be clocked off the chip and sent down to the computer in real time. So you basically had to own the CPU. Click, 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 like that, right? Because you're reading the data off the chip. Well, now Windows comes along, it's a multitasking system, and sure enough, you can context switch and something else can happen, and that image can be read partway off, stop for a minute, and then read some more down, and you end up with horizontal banding because the dark current's different, or that horizontal banding. So now they have the things, well, we have to put it on high priority. Well, that locks everything else out on the CPU. That's just plain dumb for a $20 buffer chip. Fortunately, all but one brand of camera, and I was told, the guy wouldn't tell me which one it is, but there's still one unbuffered camera being sold out there right now, but pretty much everybody else's are buffered. So I'm thinking that it's the same, and it took 10 years. 10 years for that to go away. So I'm hoping it won't take 10 years for the CMOS cameras to do onboard stacking instead of forcing everybody to download monster amounts of data and then stack them in like SharpCap does or something. That's a cool program, and it is cool that you can see it kind of appear in front of your eyes, but it's a two-edged sword. How are you going to get that kind of data across anything but high-speed USB or something like that? So, Linda, did I get deep enough on that to give you a better answer? Did that really cover what you were hoping for? You can answer me right on the chat. Okay, well, if there's another question, I'm saying...
I do have one. As an imager, I don't need to do anything about Alpaca except get people to start using it for my new devices.
That would be the yes, but that is that goes right along with Dex's question about are SBIG and FLI creating Alpaca drivers. Beats me. I would encourage you to ask them. Communicate back to these. What I got on my little rant a while ago, and I'm sorry I got really wound up about that, but the reluctance for people to provide feedback to these manufacturers for what they actually want. And then I turned around and said, don't ask them for Alpaca because it'll take a while, right? So there's a balance in there.
No, I mean just as a practical
They kind of have to know that it's out there and that you're looking down the line for something.
You're focusing on the second part of the question. I'm just saying that as an imager, I don't need to do anything to get Alpaca.
No, you won't. It's just plumbing. You don't have to do anything to get ASCOM either. I mean, you're either gonna. The only thing
I have to go download the environment and the individual drivers for ASCOM, but I don't have to do anything for Alpaca.
Well, you might if they don't. If the manufacturer, the vendor doesn't deliver a driver, you have to load drivers for printers too, right? I mean, it's pretty much any kind of device you put on a Windows system, even stuff that you plug into your USB, they'll give you a driver for it, right? So that's not something that's ever going to go away. Whether it's Alpaca or whether it's COM or what, if you buy a new device and it doesn't have everything internal and with its own Wi-Fi or its own Ethernet port, yeah, you're going to have to put a driver in. Well, the ASCOM platform is there to help driver writers reduce their workload. So that's really what that's, and to provide the chooser mechanism. Those are the two reasons for the platform. But once you install that, now it's there, it is. And you just put, you buy something, you put the driver in and you use it. So Alpaca won't get rid of the need for drivers unless somehow it's all self-contained. So for example, if you bought a focuser that had its own built-in Wi-Fi, that ran off a Raspberry Pi or something like that with its own Wi-Fi, then no, you wouldn't have to put a driver in. It would be accessible directly from the focuser program. But actually the driver's inside the little box.
Is it safe to say that one of the goals of the Alpaca effort is to have manufacturers have an Alpaca interface in it so that my software will be able to tell their device how to work?
Actually, that's the goal of ASCOM, period. Whether it's Alpaca or COM. That you just said what ASCOM is for. It's to provide an ecosystem in which programs and devices can talk to each other without the programs having to know or do or jump through special hoops for each device. The program gets to speak the same language and expects the same behavior from all the mounts out there, including the ones that come along after that program was written. So if you write a program for something this year and next year a new mount comes out, your program should be able to talk to that mount without any changes. And there's a tool inside that for driver developers, I don't want to get too much into the development part of all of this, but there is a tool that will validate that behavior. It'll validate the interface and it'll also validate the behavior. So that's out there and people are encouraged to use it. And so that's how we try to do quality control.
Okay, well, we're going to be wrapping up here. Linda's made a comment about that she likes the idea of more devices implementing Wi-Fi and providing an Alpaca interface in the device to reduce those USB cables hanging around. And I think we've responded to all the comments and questions. Bob, if somebody wanted to get a hold of you, where would be the best place to get a hold of you?
Our Denny let me see, how can I put this out here? I don't have a real, I wasn't really, let's see, maybe I can actually.
What company are you with? If they Googled
DC3 Dreams, let me do this. Let me put
Can
something.
you show us the website?
Yeah, just a sec. DC. It's the easy one is dc3.com. That's it. davidcharles3.com. So if I now try to rip this thing off of here and share my screen share, I guess I can't share one window, so I'll just maximize this like that. There, how's that? Can you see all that?
Thank you.
Okay.
What is it again?
dc3.com.
Okay.
And here's the whole website.
I'm going to put the link on the bottom of the video.
Oh, wonderful. So you can see each of the products is here. And you can, there's me. And well, I am one of the products because I'll say this for everybody. Our main motto is software is a service business, not a product business. So actually I am one of the products. When you buy tech support and upgrades, you get Bob's Tech Support. So there it is. And there's our contact info. I don't have a magnifying glass. How would I get one of those? I don't even know. Magnifier? Let's see.
I don't really know myself.
Magnify portions of the screen using the magnifier. Alrighty. Well, I got a great big control panel with about 400 check boxes on it. I think I'll skip that.
Yeah, don't try to learn new things as you predict.
Right. No thanks. All right.
Okay.
So I'll unshare my screen now.
If you'll excuse us here, we usually get some people asking us questions, and Glenn has asked a question about hey, Bob, maybe you can help with this. What kind of cameras do people use for seeing their equipment? Okay. In other words, I, for instance, have I sit in here and image all the time. I tell my computer to go take pictures out there, and my observatory's in the backyard, and I don't go out there because it's cold out there. If I wanted to watch my equipment, what kind of camera should I be using? Now, that's a question for everybody in the group, and I see nobody has popped in with an answer for Glenn here. Has anybody got any ideas? Tolga, you got any suggestions? Anybody? Oops.
There's all kinds of webcams out there. That's what most people use. Some of them have night vision capabilities, but you have to be careful because if they have those infrared illuminators, that can wreak havoc for your imaging. So you have to be careful with that. But some of them are night vision capable, meaning that they're low light capable, not that they have those ring of LEDs around them that shine infrared out. That'll light up your thing like a Christmas, like daylight, and you'll get fog on your images. So, but webcams would be the way to do it. Some of them you can even tilt, and aim around. And there's a million of them out there, but that's what I would use, would be a low light webcam.
Just make sure they don't have an LED illuminator on them.
Right.
Okay. And Larry Groom says he uses a FOSCAM, FOSCAM.
You could use those cameras that have the LED. They usually have a mode that you can turn the LEDs off.
Right.
And what you do is that, this is what I recommend. Like, you never leave those LEDs on, because our cameras we use, they're sensitive to infrared, so they'll record that signal. So what you want to do is that if you really want to see, you just turn it on for a second and then turn it right back off.
There you go. Yeah.
Okay.
Hi, Larry. Larry Groom. He's one of our guys. That's cool. Good answer, Larry. Thank you.
Okay. That wraps it up for tonight. We're going to stop the broadcast. We'll be back next week with Tom telling us about some high resolution imaging. And we've got, as you know, the next 2 or 3 months filled with some really good speakers and presenters. And we're going to be doing some processing along the way. If you've got any ideas about how to make the channel better, please send them along. Really appreciate everybody being here tonight. And so we're going to stop the broadcast. Good night, everybody. Have a happy Easter.
Good night.